Hey guys, today we are going to learn about statistical distribution. Have you ever wondered how randomness rules the world around us? From rolling dice to predicting the weather and also playing games like Ludo, it is all about statistical distributions. So, what is statistical distribution? You ask me. Imagine you're throwing a party and all your guests are like numbers. They're dancing on the floor, and some are sitting on the chairs. Some are like outliers, breaking it down to the edges. Well, but why should we care about all these statistical distributions? If you're involved in solving the mysteries like a data scientist or a detective, then understanding how data is spread out is very important. Whether you're crushing numbers in statistics class or building the next big AI model, distributions are your trusty sidekicks. In this video, we'll learn about the definition of what is statistical distribution and why they are important, and where it is used in machine learning algorithms, how the data is used, and what are the key distributions. We have various distributions like uniform distribution, binomial distribution, and so on. We'll be going to learn all of these and the real world applications. Where are they applied in our day to day life? And also the core concepts like what are the parameters and probability density functions and probability mass functions of each of the distribution. So let's get started, guys. So what is a statistical distribution? Statistical distribution is a mathematical function that describes the likelihood of different outcomes or values within a data set. In simpler terms, it shows how data points are spread or distributed across a range of possible values. It is like carom board, and you can see when you start playing the carom board, all the caroms will be spread out like this, right? So you can see more of the coins here spread out, and this is the your target where you are going to strike. If there are more coins here, you are definitely going to hit at least one of that into the hole, right? So understanding the statistical distributions can increase the possibilities of you to win. Range of values. What are the range of values involved in the statistical distribution? It covers all the possible values that a variable can take, from smallest to the largest. Statistical distribution also involves the probability functions. It assigns probability to each of the possible value, indicating the likelihood to observe that value in a data set. We have different types like discrete statistical distribution and continuous statistical distribution. These distributions can be derived using probability density function and the probability mass functions. So discrete random variable is nothing but having countable possible outcomes. For example, if you are rolling a die, there are six possible outcomes, right? So that is a discrete random variable. And what is continuous random variable? Continuous random variable is nothing but having infinite number of outcomes. For example, the heights of a student in a class. In a class, there will be so many students, and their heights will follow a probably normal distribution. As per the experiment conducted by the doctors, we can see that the heights and weights of the students in a class follows the normal distribution. So knowing these distributions will help us in accomplishing many things. The shape of the distribution can vary widely, so each of the distribution has a different shape. So for normal distribution, we have bell shaped curve. Let me erase this one. For a normal distribution, we have a bell-shaped curve like this. So this is the shape of the distribution. And for uniform distribution, we have like this uniform distributed data. And also for Poisson distribution, we have another shape. So the shape may vary, but the concept you have to understand it. Next, what is the importance of statistical distributions? So they are used in modeling the real world phenomena. They are used in predictions about the future outcomes. For example, the weather, if it is going to rain tomorrow or not. They'll be calculating these predictions based on these distributions. Based on the past data, they'll be calculating what is going to happen tomorrow. This is nothing but calculating the probability using the statistical distributions, and also these distributions help in summarizing the data and also the hypothesis testing. Foundation for machine learning algorithms. Statistical distributions and probability are the base. You have to learn these from scratch so that you can build an amazing machine learning algorithm that performs really well. Okay, so what is the risk management and decision making? Using the statistical distributions, we can also make important decisions, and risk will be managed with this. Improving algorithm accuracy. Using the parameters in these distributions, we can optimize the performance of the model. We have various types of statistical distributions: uniform distribution, binomial distribution, Bernoulli distribution, Poisson distribution, normal distribution, and these we rarely use. These are the important distributions that you have to know if you want to become a data scientist. So let's go and catch up with these each of the distributions. What is uniform distribution? What is uniform distribution? It is the probability distribution where all outcomes are equally likely. If you take, for example, tossing a coin, we have two outcomes, head or a tail. The probability of getting a head and tail is equally likely, so that follows a uniform distribution. There are two types of uniform distributions. This uniform distribution can be derived using two different probability functions. For discrete uniform distribution, we use the probability mass function. What is discrete uniform distribution? In probability theory and statistics, the discrete uniform distribution is a symmetric probability distribution wherein the finite number of values are equally likely to be observed. Every one of the n values has equal probability 1 by n. So, for example, if you toss a coin, it will have a head or a tail as the outcome. So, they have equally likely chances of occurring when you toss a fair coin. It follows a discrete uniform distribution. It has finite number of outcomes. We can count these outcomes, right? There are two outcomes. This may occur or this may occur. As per the probability mass function, the probability of this uniform discrete distribution is nothing but 1 by n if x belongs to A. A is the combination of all the outcomes. Here there are two outcomes, so here A will be uh, heads comma tails. There are two outcomes, right? So here 1 by n, x is nothing but the random variable. This is the probability 1 by n. The probability of getting a head is 1 by, there are two outcomes, so 2. N is nothing but the number of outcomes. The probability of getting a head is 1 by 2, and the probability of getting a tail is 1 by 2. Both are equally likely to occur. Here this is the graph of a uniform discrete distribution. So here there is one outcome, and this is one outcome, and this is one outcome, this is one outcome. All have the equal chances of occurring, so this graph is on a same level. It is not increasing or decreasing. So this A is the starting point and B is the last. So we'll take an example, rolling a dice. If it is a fair dice, we have six outcomes: 1, 2, 3, 4 and 5, 6. Probability of getting one is 1 by 6. Probability of getting 2 is 1 by 6. So all the probability of getting a number from this sample space is 1 by 6. It is equally likely. Here, here the n is 6. 6, right? There are 6 outcomes. And b is nothing but 6. And a is nothing but 1. B is the largest number because here on the x-axis it is here. So B is the largest number and A is the smallest number. So n is given as B minus A plus 1. If you use this formula, you will get what is the n value. So B is 6 minus 1 plus 1, you get 6. So the probability of getting 1 or any of the outcome, it is 1 by n. N is nothing but we got 6. So it is 1 by 6 for all the numbers on the dice. So we'll write it as this a comma b, and the parameters used in this discrete uniform distribution are a and b, where b is greater than or equal to a. This b should always be greater than or equal to a, then only we'll use this discrete uniform distribution. And as we know, this probability mass function will be 1 by n, and the mean and median will be same for this discrete uniform distribution, that is a plus b by 2. So for example, where we use this is in gambling. So drawing a card from a well shuffled deck, we have 52 cards, right? So the probability of drawing a card from a deck of cards is nothing but 1 by 52. Now we'll learn about continuous uniform distribution. What is continuous random variable? We have to note that continuous random variable is nothing but the uncountable uh, outcomes. For example, the height of the students in a class, that is uncountable. The probability will lie in between the numbers. It is not exactly a round number. For example, here selecting a number between 1 to 10, we have numerous numbers in between 0 to 10, like 0.1, 0.2. We have many numbers. So that is continuous random variable. For continuous random variables, we use this continuous uniform distribution. So it is also called as rectangular distribution. It's a family of symmetric probability distributions. So the uniform, um, this will be like this, right? It is symmetrical. If you draw a line in between, sorry, I'm unable to draw this properly. If you draw a line in between, the left side and the right side will match. That is known as symmetry. So this discrete uniform distribution and continuous uniform distribution follow the symmetric probability distributions. So probability, the outcomes lie between certain bounds. Here the bounds are A and B. Between A and B, the probability will lie. It is first denoted as U A comma B. A is greater than minus infinity, B is greater than A, and B is less than plus infinity. So here in the graph you can see this is the graph of the continuous uniform distribution. It can be derived from probability density function. Probability density function is used for continuous random variables. Because this is continuous uniform distribution, we are using probability density function to derive this distribution. So here previously for discrete uniform distribution, we saw that here it is 1 by n, but here it is 1 by b minus a. On the x-axis we have a and b. This is the starting of the distribution and this is the ending of the distribution, and this is the f of x function on the y-axis. X-axis is nothing but the random variable. If x is between a and b, then it is the probability of that random variable will be 1 by b minus a. For example, if the x is lying here, and the probability will be 1 by b minus a. If it is not inside this, in between this b and a, if somewhere here the random variable is, then it will be 0. The probability will be 0 because it's not possible, right? Probability is always between 0 and 1. Cumulative distribution function will always be in this shape. For any distribution, we can see it always follow an S shaped curve. Here will be the a. We can see this is the a and b. The probability of x lying between a and b will be this one, and if it is less than a, then it is 0. You can see here 0, and if it is more than b, it is 1. For a continuous uniform distribution, we have mean 1 by 2 a plus b and median 1 by 2 a plus b. They both are same, and the variance will be 1 by 12 b minus a whole square. We just need to know the formulas, no need to know the derivation. So imagine you have a candy shop, and we have per day maximum sales of 40 candies and a minimum sale of 10 candies. So what is the probability of daily sales to fall between 15 and 30? Here this is the graph of this distribution. So maximum value is 40 and the minimum is 10. This is same as the graph we saw this. Here b is nothing but 40 and 10 is nothing but a, and this will be 1 by b minus a, that is 40 minus 10, 30. So what is the probability of the daily sales fall between 15 and 30? We have to calculate this yellow part. What is the probability that will lie there? Using this uniform continuous distribution graph, we can get many insights like this. So let's find out what's the probability that we can sell candies between 30 to 15. So this will be calculated as x2 minus x1. x1 is nothing but 15 and x2 is nothing but 30. So 30 minus 15 into 1 by b minus a, that is nothing but 30. That is nothing but, here we get 50%. There's a 50% chance that in a day we can sell the candies between 30 to 15. What is the probability that x is greater than 20? We can find it using the same formula, 40 minus 20. Here this part we have to calculate, that is 40 minus 20, x2 minus x1 into 1 by b minus a is nothing but 40 minus 10, the actual value of the distribution. We get 66%. So there's a 66% chance of selling more than 20 candies a day. So using this distribution and calculating these distributions, we can also have a chance of increasing our sales and getting more profits. We'll also consider one real world example, that is, imagine you're at a carnival and there's a prize wheel with numbers from 0 to 10. The wheel is perfectly balanced, so when you spin it, any number between 0 to 10 is equally likely to come up. Possible outcomes are any real number between 0 to 100, that is these. So these are all the real numbers that are between 0 to 100. There are countless possibilities. That is why they follow continuous uniform distribution. So I hope you have understood all the concepts in this uniform distribution. Now let's learn about the next distribution, that is Bernoulli distribution. This single trial with two possible outcomes. The most common example is flipping a coin, that is having heads and tails on each side. When we flip a fair coin, we get head or a tail, not both. That follows a Bernoulli distribution. Bernoulli distribution always have two outcomes only, not more than two, and it is the simplest discrete probability distribution. Discrete probabilities are having countable outcomes. So this is discrete probability distribution. So we use probability mass function to calculate the probability of a Bernoulli distribution. It represents the probability distribution of a random variable that has exactly two outcomes, that is success represented by p and failure with the probability 1 minus p. It is also known as q sometimes. So it is used to model binary outcomes such as coin flip or yes or no question. This is the graph of Bernoulli distribution which follows probability, which uses probability mass function. Here we can see three examples. Here the random variable 0 is equal to 0. 0 in the sense failure. We are suppose we are taking 0 as the failure and 1 as the success. Probability of getting 0, that is probability of being a failure, is nothing but zero point 0.2. If we have the zero point 0.2, then the probability of the success is zero point 0.8, because the probability lies in between 0 and 1. Here you can see this red colored bar is nothing but zero point 0.2. Then if the random variable is 1, then it is zero point 0.8. Probability of getting 0 is zero point 0.8, means probability of getting 1 will automatically become 1 minus zero point 0.8, that is zero point 0.2. Probability that x is 0 is zero point 0.5, that is x equal to 1 will be 1 minus zero point 0.5, that is zero point 0.5. So the main points of these Bernoulli distribution is nothing but it has a discrete random variable and uses probability mass function, and the outcomes will be success or a failure. There are only two outcomes, and the parameters are p, q. P lies between 1 and 0, and q is nothing but 1 minus p, and k is nothing but the outcome success or failure 0 comma 1. If k is a random variable with Bernoulli distribution, then probability of x equal to 1 equal to p, x being a success 1 equal to p, equal to 1 minus probability of x being a failure, that is 0, equal to 1 minus q. The probability mass function f of this distribution over possible outcomes k is, k are the number of possible outcomes, 0 and 1. 0 is the failure and 1 is the success. So if k equal to 1, if k is success, then we will have the probability mass function of the distribution as p. If k equal to 0, then it will be q, that is 1 minus p. So this can also be expressed as this. This is only for one trial. Here for one trial we have two outcomes. The Bernoulli distribution can be denoted as Ber p. What is the expected value? So the expected value is nothing but p for Bernoulli distribution. Mean and the expected value both are the same for this distribution, and it is equal to p is nothing but success. What is the variance? The variance of the Bernoulli distribution is p into 1 minus p. This variance will be calculated to find the spread of the data. So we'll take an example. A company asked you to review a newly launched smartphone. You liked 60% of the features and disliked 40% of them. Let's calculate the Bernoulli distribution using probability mass function to analyze the preferences. So here 0 is nothing but you didn't like that much, and 1 is nothing but you liked, you want to keep the product. 60% you want to keep the product, and 40% you don't want to keep the product. So 60% is taken as p, the success, and this is taken as q. As per the probability mass function, we have p power k into 1 minus p power 1 minus k. If k equal to 1, that is probability of getting, I mean the probability of being the success, that is you keeping the phone without returning, that is p power 1, 1 minus p power 1 minus 1. You just have to substitute k equal to 1 here in this formula, then you'll get p. P is nothing but success. If probability of k equal to 1, then it is p. The probability of k equal to 0 is nothing but q. When you substitute 0 here in this formula, you'll automatically get 1 minus p, that is q. What is the mean of the Bernoulli distribution? So these statistical measures you have to know for every distribution. Let's see what is it. The expected value is sigma x equal to 0 to 1 k into P of k, where k is 0 comma 1. Here you can see this is the summation formula, k into, if the k is 0, here k is 0 to 1, only two outcomes. So first we are substituting k here. If we substitute k, then uh, into p of k, if k is 0, then we have seen that it is q is nothing but 40, that is 0.40, plus if k is 1, 1 into p of k equal to 1, p of k equal to 1 is nothing but p, p is nothing but 60%, that is 0.60. When we add these both, it is 0.60, that is p. So the expected value is p, expected value, and the mean is p, always for the Bernoulli distribution. What is the median for the Bernoulli distribution? It is 0 if p is less than half, if it is less than 1 by 2. That is a chance of you buying the phone. If it is less than half, less than 50%, then it is a failure, right? And if it is equal to half, that is if you're giving your rating and you like the product 50%, then the median will be between 0 to 1. And if the p value is greater than 1 by 2, then it is success. You keep the phone, you won't be returning it, right? Then what is the mode? See, if p is greater than q, then p will be the mode, and q is greater than p means q will be the mode. What is the variance? K equal to 0 and 1. Here we got in the above example, we got p of k equal to 0 is 0.4 and p of k equal to 1 is 0.6, that is 60%. Standard deviation equal to a root of pq. If we bring the square root here, it will be variance. Standard deviation square is nothing but variance equal to p into q. Now let's learn about what is binomial distribution. You have played Ludo, right? So we will roll the dice many times and we will reach that point where we win the game. So that game follows binomial distribution. It is a series of Bernoulli events. So each event has some outcome, and that event will be repeated many times, then it follows binomial distribution. The binomial distribution has two parameters, n and p. N is number of trials and p is success, and it is the discrete probability distribution because it has discrete random variable. So the number of success in a sequence of n independent events, all the events should be independent to follow this binomial distribution, and it should have outcomes, only two outcomes, like a yes or no question or a head or tail or success or failure. We have only two outcomes in this binomial distribution as well. The success will be written as p and the failure will be q 1 minus p, same as in the Bernoulli distribution. If the n equal to 1, then that is a Bernoulli distribution. If n is more than 1, then it will come under binomial distribution. Binomial distribution is the basis for popular binomial test of statistical significance. Let me give you an example. Flipping a coin multiple times to count the number of heads is a binomial event. What are the characteristics of this distribution? Each trial should be independent and there will be only two outcomes, success and failure. Also, this will have discrete random variable. Since this distribution has discrete random variable, we have to use probability mass function. The binomial distribution is derived from the probability mass function. We have parameters like n belongs to natural numbers, q and p are in between 0 and 1. P is nothing but 1, that is success, and q is nothing but 0, that is failure. Only two outcomes we have, and it is denoted as b n comma p. The probability of getting exactly k success in n independent Bernoulli trials. That can be written in this formula: np power k 1 minus p whole power n minus k. This is a very simple formula. Here the k values lie between 0, 1, 2, 3, and so on, where this n k is nothing but n factorial by k factorial into n minus k factorial. This n factorial by k factorial into n minus k factorial, this is called as binomial coefficient. So if p is 0.5, that is probability of success is 0.5, then n will be the n is nothing but 20, that is 20 times. If we conduct that experiment, then we will have a distribution like this blue color one. It somewhat looks like a normal distribution, and if the probability of being success is 0.7 when it is conducted for 20 times, then the distribution looks like this green color dotted graph. The same way goes for this. As the number of trials increases, the graph is getting smaller, and this is the cumulative distribution function. This is as usual the S shape. What is the expected value for binomial distribution? It is n into p. N is nothing but number of trials and p is the probability of success. The median will be in between np and np. The median and mean will be equal, that is np. In the binomial distribution, we have two modes, that is this and this. If p is 0, then the mode is 0. P is 0, then the mode is 0, and if p is 1, then the mode is n. What is the variance? We have variance np into 1 minus p. The standard deviation is root of variance, that is square root of np into 1 minus p. So let's see an example here. What is the probability of getting 3 heads in k flips? So here the number of trails is nothing but 5 flips, and the probability, how many times we want it to be succeeded? 3 times. We want exactly 3. So k equal to 3. N c k. N is nothing but 5. C k is nothing but 3 into p. The probability is 0.5 of getting a head. So 0.5 into 1 minus p. P is nothing but 0.5 power n minus k, that is 5 minus 3. This we get as 0.31, that is 31% chance of getting exactly 3 heads in 5 flips. Like this we can calculate the probability in our day-to-day life as well. So let's see a real world example where there you need to do a quality check. So you are inspecting 10 items in a factory where each item has 10% chance of being defective. Number of trails, there are 10 items, so 10 items is nothing but here number of trails. So the probability of being defective, here this 10% chance we are taking it as success. That is what is the probability of the item being defective? That is 0.1. Number of success varies from 0 to 10. We don't know how many are defective. It may be between 0 to 10. There might be two items defective, or 10 items, all the 10 items defective. We don't know. So we have to check what is the probability of finding exactly two defective items in the sample of 10 items. Here we have k. We want to see exactly two defective items. What is the probability of finding exactly two defective items in a sample of 10? We can just substitute these values in the formula. NCK. N is nothing but 10. C k is nothing but 2, and the probability of getting a defective item is 0.1. The 0.1 into 1 minus p, that is 1 minus 0.1 power 10 minus 2. We get 0.131937. So there is 19% chance that there are exactly two defective items when we have 10 items. So this is really important in manufacturing industry to know what items are defective and how to control it. Well, let's see one more an example. So if you know that an operation has 90% chance of success, 90% chance of success is nothing but p equal to 0.9, and you perform 10 operations, n equal to 10. You can use the binomial distribution to calculate the probability of different number of successful operations, such as the probability of exactly 8 successful operations. So what is the probability that you will successfully complete 8 operations? This is up to you for calculation. Now let's talk about the next distribution, that is Poisson distribution. It is not Poisson, it is Poisson distribution. I have included this. You can just read this. This is the only distribution which is not symmetric. Here you can see it is skewed. The shape of this distribution is based on the expected number of events per time unit. It has a discrete random variables, and this distribution is a discrete probability distribution that has a various number of events occurring in a given fixed interval of time. So in a given time there will be series of events occurring that follows this Poisson distribution. We have numerous examples where this Poisson distribution can be seen. It is number of meteorites greater than 1 meter diameter that strike Earth in a year. Number of people visiting the bank, the number of laser photons hitting a detector in a particular time interval. So this Poisson distribution always linked with the time interval. This is a skewed shape of graph. Here on the y-axis there are number of people visiting a bank. These x-axis is the time interval at 12 p.m., 1 p.m., 2 p.m., 3 p.m. till 5 p.m. So there is only one person visiting the bank at 12 p.m. There are two people visiting a bank at 1 p.m. and so on. So we in this distribution we can see the maximum number of people visiting are at 4 p.m. That is 4 people are visited the bank at 4 p.m. This Poisson distribution will be calculated using probability mass function because it has discrete random variable x. Here the parameter we have is k and lambda. Lambda should always be greater than 0. And just remember this formula. Well, in machine learning, we use just 2 3 lines of code to implement this. Here, k is the number of occurrences. E is the Euler's number, that is fixed number 2.71828, and k factorial k into k minus 1, so on. This is the factorial value. Probability mass function. The shape of the graph is skewed, always skewed. We can observe that if lambda is increasing here, yellow dots are connected when the lambda is 1. If lambda is 4, then it follows this distribution curve. And as the lambda is increasing, curve is becoming more symmetric and approaches a normal distribution. When lambda is low, the distribution is right skewed. The highest point on this graph represents the mode of the distribution. Here is the notation. This is Poisson, also known as lambda. The parameters are lambda that belongs to 0 to infinity. Lambda can be any value here in between 0 to infinity. And k belongs to natural numbers starting from 0. Mean and variance for this Poisson distribution equal to lambda only. Let's see an example. On a particular river, overflow floods occur once every 100 years on average. Calculate the probability of k equal to 0, 1, 2, 3, 4, 5 or 6 overflow floods in a 100-year interval. So there is a time interval given, and also the k values are ranging from 0 to 6. Assume the Poisson model is appropriate because the average event rate is one overflow per 100 years. There is only one time flood occurs in every 100 years on an average. So lambda equal to 1 probability of k, that is overflow floods in 100 years. Here we have considered lambda as 1. So when we substitute the values, we get this. If k equal to 0, 0 times the flood occurs in 100 years. That is no flood occurring in 100 years. The probability is 0.336. Probability of flood occurring one time in 100 years is this, the same, both are same. And k equal to 2, that is 2 times there is a flood in 100 years, the probability is 0.18. Like this, we for each k value we have different probabilities calculated. Probability that the flood occurs 6 times is very less, that is 0.005. That's it about Poisson distribution. You can research and learn more real world examples where you can apply this Poisson distribution and calculate the probabilities. Let's go ahead and learn about the last distribution we are going to cover in this video. It is the normal distribution. Normal distribution has continuous random variables. Normal distribution is also known as Gaussian distribution. Since it has the continuous random variables, we use probability density function to calculate this distribution. So the formula goes by f of x equal to 1 by under root 2 pi sigma square e power minus x minus mu whole square by 2 sigma square. The sigma is nothing but the standard deviation. Sigma square is nothing but the variance. And mu is mean. X is the variable. This is the probability density function of the normal distribution. You can see the mean, if the mean is constant, but the variance is increasing. If the variance is increasing when the mean is constant, then the graph, the curve is getting wider. Spread of the data is more when the variance is more. And this highest point of this graph tells us the mean. So here you can see the mean is 0 for all these three graphs. This green graph has mean -2. Red bell-shaped curve is the standard normal distribution. Curve of this normal distribution is always symmetric. This is the cumulative distribution function S shape, and all these three curves have the same mean, that is 0, but different variances. As the variance increasing, the curve is getting straight, right? The main parameters in this distribution are mu, that is mean, and sigma square, which is variance, and x belongs to r. These all belongs to r, and this variance should be greater than 0. So where does this normal distribution come into play? If we are in a class, the weights and heights of the students follow this normal distribution. Mean, median, mode are all equal for this normal distribution. Mean tells us the peak location. Standard deviation controls the width of the curve. And a small standard deviation results in a narrow curve, while a large one leads to a wider curve, as we saw here. What is this empirical rule? It is the thumb rule in normal distribution, the 68, 95, 99.7 rule. What is this? The 68% of the data fall in between this. So this, if this is the normal distribution bell curve, from here to here is the 68% of the data, and from here to here is the 95% of the data falls in between two standard deviation, and 99.7% of the data fall in between three standard deviation. These are the formulas. This is one standard deviation, 68% of the data falls, and two standard deviation, 95% of the data falls in between this and this. So let's calculate the SAT scores. If the mean is 1150 and standard deviation is 150. So when we substitute these values in the above formulas, we can see that this 1150 minus 150 here, if we substitute, it will be 1000 and 1150 plus 150 here, if we substitute, it will be 1300. So in between 1000 to 1300, 68% of the scores lie. Here 34% and 34. These are equally divided because this graph is symmetrically distributed. The remaining part is this. In between 850 and 1450, 95% of the data is distributed. And in between 700 and 1600, the 99.7% of the data is distributed. So this normal distribution gives us many insights of how the data is spread and divided. As we saw earlier, this is the formula where x is the value of the variable, f of x is the probability function, and mean is mu, sigma is standard deviation, and sigma square is variance. Always the area under the normal distribution graph is equal to 1, that is 100%. We calculate the area under this curve, that will be equal to 1, that is 100% of the data will be present under this curve. The total area under the curve is equal to 1, representing the probability of all possible outcomes. What is standard normal distribution? Standard normal distribution is a special scenario where the mean is 0 and the standard deviation is 1. It is also known as z distribution because we'll be calculating the z score in the standard normal distribution. This will be really very helpful in machine learning algorithms where we standardize the variables, the features. We use z-score to convert any normal distribution to standard normal distribution. So this is very important. Z-score tells you how many standard deviations away from the mean each value lies. So this x is the value, and z-score tells us how many standard deviations away the value is from the mean. This is the simple formula which is used to convert the normal distribution into standard normal distribution. Let's see how it is calculated. Also, the z-scores can be converted to probabilities, the p-value, to determine the likelihood of values occurring below or above a certain point in the distribution. Let's understand this point using the below example. So first, let's calculate the z-score of a random variable which has these values 1 2 3 4 5. So the mean of this distribution is 3 and the standard deviation is 1. We can simply calculate this mean by adding all these values and divide by number of values. We get 3, and standard deviation we can easily calculate using the formula. This is the normal distribution where the values are like this 1 0 1 2 3 4 5 6. Using the z-score we can convert it into the standard normal distribution which has the standard values. The mean will be 0 and the standard deviation is 1. Here the z-score is calculated by xi minus mu by sigma. After calculating the z-scores we can get a new distribution which is in a standard form, that is y, which when plotted it is standard normal distribution with a mean 0 and standard deviation 1. Here now let's calculate, let's put the first variable xi. 1 minus mu is nothing but 3. Mu is already we have 3. 1 minus 3 by 1 is minus 2. So we get a new value for the variable y. and here x2 is 2. From here minus 3 by 1 equal to minus 1. And the same way, if we calculate for all these numbers, we get new values: minus 2, minus 1, 0, 1, 2. When plotted, we get the standard normal distribution. So where we exactly use the z-score. If for example we have a data set which has ages in years, weights in kgs, heights in centimeters, salaries in INR. So if we want to build a model for all these features, then how we are going to use these features in the model, because these are all of different measurements. To standardize these, we use z-score, convert all these features into one single unit. The standard normal distribution or standardization is used in ML models like clustering algorithms, linear regression, logistic regression, and many more. Let's take a real world scenario. What is the probability of the SAT score in your sample exceeding 1380? This is the distribution of the SAT scores. So, what is the probability that how many what is the probability that it will exceed 1380? The scores will exceed 1380. Let's find out it using the z-score. We have the mean 1150 and standard deviation 150. Let's substitute the values here. We get z-score as 1.53. For a z-score of 1.53, the p-value, the probability value will be 0.93. This can be seen in the z-score table. 0.937. The probability of SAT scores being um, 1380 or less, that is 93.7%. And it's the area under the curve left of the shaded region. So this part is the 93.7%. So we want to find more than 1380. To find this shaded region, we will subtract 1 minus this shaded region. This shaded region we already got it as 0.937. Why we are subtracting it from 1? Because the area under this normal distribution curve is always 1. So 1 minus 0.937, that is 0.063. That means it is likely that only 6% of the SAT scores in your sample exceed this. Only 6% chance that the SAT scores will be above 1380. Using this curve, we can find so many insights. Hold on, we have not yet completed this video. We have an interesting part yet to come. We have designed a game where you can learn all these distributions in a go and become a pro. After learning all these distributions, I think you are pretty much bored about all these lectures theory part. But now, to liven things up, I've designed a game. Anyone can play this game. So let me explain how this game is played. The setup is each player gets a game piece to move around the board. For example, the Ludo or Monopoly. The activity, you can keep it two activities or more than two activities. The board has different types of spaces like properties in Monopoly and special zones and action cards. Gameplay: players take turns rolling a six-sided die to make moves. When you land on a property, you can choose to buy it or not, and a landing on special spaces might trigger rare events like bounces or penalties. Scoring: the goal is to accumulate the highest score by the end of the game. Points come from buying properties, collecting bonuses, and avoid penalty. Winning: The player with the most points at the end of the tournament wins. This game is all about rolling dice, making strategic decisions, and aiming to come out on top with the highest scores. This game gives you a nice understanding of the distributions. I hope this game will really boost your interest in these statistical distributions. Let's conclude the video for today. We have covered various distributions like uniform distribution, Bernoulli distribution, binomial distribution, Poisson distribution, and normal distribution. Hope you have liked this video. Make your learnings more fun and interactive by playing the interactive game. Have fun, enjoy learning, and keep learning. Bye bye.